How often do you
Yeah.
do such podcasts?
How often?
Yes.
So we rotate between ourselves, so it's not just me or Gitika. It rotates across the team, but we do an episode about once a week, at least. Yeah,
Personally, your team.
the team. So everyone on the team will. Yeah. This is my, I don't know, almost 10th episode. I've done a few. Yeah.
Okay. This is our first.
Okay, we are live right now actually, and everything
Yeah.
looks to be fine.
Looks good.
Yeah, I think we are good. Yeah.
All right.
So, oh, we can actually change it. Do you want me to do that? We still have a lot of time left.
Yeah. Let's go off live here, change it, and then maybe we can do the video.
Yeah. If I end broadcast, it will just stop everything.
Oh, will it?
Yeah. If I do
Okay.
end broadcast, yeah, that's why I was like, if I test it out, we have to at that point continue.
Gotcha. All right. Well, then we'll stay on this and then just switch over when we need to.
We can take like 2-3 minutes break if someone wants to go and come back. I'll put everyone down. And then once we are ready, probably we can come back by 5:56-ish, 3 minutes from now. And then I can put everyone back up and then we can change the channel.
All right. Are we live?
We are live.
Nice, nice. And we're coming to you live from all over the world this time. We're in Austin and San Francisco and in Bucharest. We've gone international. Howdy Partner goes international. Oh man, so excited to be here. It's been too long for me. Yeah, why don't we kick things off? Gitika, why don't we introduce yourself in the show?
Yeah. Hi everyone, I'm Gitika. I'm a partner solutions architect with AWS. And if you do not know what Howdy Partner is, it is a developer focused show that puts AWS partners in the spotlight to show you how to use their products and how to go about it when building on AWS.
Right, right. And today we have some very special guests with us today who are going to be teaching us all about IoT and Alexa and frustration-free setup. Our friends over here at NXP. But again, if you're new to the show, if you're a developer or an architect, follow along. Our friends at NXP here are experts in all things IoT, and they're incredible AWS partners. So we're very excited to have them. Why don't we introduce them? Dima, do we want to start with you?
Okay, sure. Hello, my name is Dima. Me and Alex, we are both from Bucharest, and we are at least I'm a software engineer at the NXP, and we are in IoT solutions from Bucharest team. Yes, Alex.
Yeah, hi, I'm Alex Marin. I'm currently a software architect within the IoT Solutions organization. And as Dima said, we are based in Bucharest, Romania.
Very cool. Very cool.
Yeah.
Why don't you tell us a bit about NXP, Alex? Alex and Dima. I want to hear a bit more about NXP. Maybe you can give us some history about the company.
Okay. Do you want to say something, Dima? You want me to say something? Okay.
Let me start. The only thing I know that previously at some point we were called Freescale, and then Alex should jump in and correct me.
Yeah, no, the Freescales and NXP history have merged only recently. NXP was a spin-off from Philips, if I remember correctly. So it was the semiconductors side of Philips. It spin off and it became a standalone company, and then it steadily grew more and more. And at some point, I don't remember exactly when, it acquired Freescale, which on its turn was spin off from Motorola. It was the semiconductors side of the Motorola company, which became a standalone company, grow as well separately until it was acquired by NXP. And yeah, right now we are one of the biggest semiconductors company in the world. I think we are very big in automotive, making basically semiconductors for pretty much anything you can think of. Any car in the world has at least one microcontroller from NXP for sure. And NXP also invented the NFC and so on. There are many, many innovations made by the company.
Oh wow, very cool.
We are very present in the infotainment business with our i.MX microprocessors.
Awesome, awesome. And you all have some demos today of some of those MCUs, yeah?
Yep.
Very cool.
Not the big microprocessors, the i.MX series, the smaller microcontrollers.
Gotcha.
Yep.
Very cool. So before we jump into those demos, why don't we kind of set the stage, AWS, IoT, and then we'll hand the floor over to Alex and Dima so they can do some interesting demos. Gitika, do you want to kick us off? Maybe tell us what is AWS IoT, and how do I build something using Internet of Things technology and AWS?
For sure. So AWS IoT Core, if you have not worked with it basically lets you connect to IoT devices with AWS Cloud without actually need to provision or manage any kind of servers. So the service can essentially support billions of devices and trillions of messages and can process and route those messages to AWS endpoints to other devices reliably and securely. So with IoT Core specifically, your applications can keep track of and communicate with all of your devices all the time, even when they aren't connected. And recently, a new feature came out. I'm not sure if you have heard of this one more. Alexa voice integration with IoT Core. This one enables device makers to make any connected device out there and have it with an Alexa built in. And to use AVS integrations, customer use a new set of AWS IoT reserved MQTT topics to transfer audio messages between device connected to IoT Core and the new virtual Alexa built-in device.
So
What this,
I have
yeah,
to
go
pause
ahead.
you there. I have to pause you there and ask you to explain maybe MQTT for those who have no history with IoT or no knowledge. What is MQTT?
So MQTT is a lightweight publish subscribe network protocol. It allows you to transport messages between devices. This protocol runs over TCP/IP, which I'm sure a lot of us are familiar with. However, any network protocol that provides ordered, it is lossless, bidirectional connection, which is done with IoT Core.
Gotcha. All right. So the standard way to communicate for IoT devices. All right. I'll let you keep going.
So when we think about IoT and AVS, why do we really care? So one of the major benefits here is that with a reduction in the engineering bill of material cost, device makers can now cost effectively build new categories of differentiated voice-enabled products such as light switches, thermostats, small appliances, which you can find around your house. What this does is it allows end user consumers to talk directly to Alexa in new parts of their home, office, or even hotel rooms for a truly ambient experience. Additionally, we have something called as Amazon frustration-free setup, which allows you to incorporate this technology into different devices and make it in a way that it is as easy as opening a box and powering on a device. So similar to if you had an Alexa at home, Echo Dot, you actually plug it in and it starts working because it's already connected to your account. Amazon frustration free setup allows you to do that.
Very cool. Very cool. And we'll dive into all of that here in a second. Um, we're about 10 minutes into the stream now, so I'll go ahead and reintroduce. If you're just joining, of course, this is Howdy Partner. We're talking about edge-ready MCU-based solutions for Alexa and for IoT. And we're actually about to dive into a few demos here from our friends at NXP. So why don't we pass it over to y'all? Alex, Dima.
Okay, so hello again. Should I introduce myself again? Maybe someone joined a bit later. So I'm Alex Morain, working within the IoT Solutions organization at NXP. First of all, I'm really glad to be here presenting our work. And before jumping to the demos side, which I'm sure that most of you will wait to see, I'll quickly introduce our turnkey solution for Alexa built-in, which integrates Amazon technologies, which were also briefly described by Gitika a bit earlier. I'm talking about AVS integration for AWS IoT Core and frustration-free setup, of course. So yeah, this solution was born from the need of having a cloud-based voice assistant closer to the user in multiple places throughout the home. It is aimed to be integrated in smart home devices like light switches, thermostats, fans, and various other appliances. In this way, making voice control omnipresent in everybody's homes. That's the goal. Um, as a fun fact and as a little bit of bragging, at the moment of its announcement, our solution was the world's first solution integrating AVS based on a microcontroller. And later on, similarly, when we have integrated frustration-free setup, it was the first solution which integrated both AVS on microcontrollers and frustration-free setup. Okay, I'm done bragging now. So, as I said earlier, our device is an Alexa built-in. What this means, what I try to emphasize is that it is not only a works with Alexa device. And I'm pretty sure that most of the audience here knows the difference, but I'll quickly explain that difference. A device which works with Alexa can be controlled by other AVS devices or can be controlled by a user through Alexa app, but you cannot talk to it directly. An Alexa built-in device has the AVS software running on it, so you can say the wake word, ask a question to Alexa, and receive replies on it. So our solution is an Alexa built-in device. As mentioned earlier, our solution is based on a microcontroller, and this enables the lowest possible cost and smallest form factor for creating Alexa built-in products. These, the lowest price and the small form factor, are consequences of the fact that on one hand, usually a microcontroller is both cheaper and smaller than the typical microprocessor you would need for running an Alexa client. And on the other hand, with our solution, we have eliminated the need for an SD-RAM memory or for an eMMC flash memory, because we can fit into the available on-chip RAM, and our code executes directly from flash. Regarding the microcontroller we use, it is an i.MX RT106A. It is part of one of the most popular crossover microcontroller series from NXP, which is the i.MX RT1060s. This is a Cortex-M7, which is clocked at up to 600 megahertz. It embeds 1 megabyte of RAM memory, and it offers a generous set of interfaces for memory control, wireless connectivity, video, or audio, of course, that we are leveraging in our solution. Okay, now for the next couple of minutes, I'll quickly share the product page to use it as a support for what I will say. Just give me a second to share the screen, please. I'm not sure if the product page is being displayed somewhere here on a banner or in the chat.
There it is.
That's the one. Yeah, I'm seeing it right now. Okay, share the screen. And can you please let me know if you're seeing the screen?
All right. Yeah, we can see it now.
Okay, cool. So this is the product page. This is where all the details about this solution can be found. This is how the device looks like, and here we are also having the board schematics, links to our SDK and to our production software as well. And I want to say a few words about hardware. So our dev kit, besides the microcontroller, it also embeds Wi-Fi and Bluetooth module, a flash, an audio amplifier, some microphones, of course, and a speaker. Now, an important thing I need to say is that we're having two hardware designs here. Our initial design was incorporated into this development kit that can be bought from NXP.com. So we call this development kit, and it's available to be acquired. But recently we have created a new design. We are calling it reference design. This we do not have a device associated to this that can be bought, but it is what we are recommended currently to our customers which are engaging with us for this solution. What is different between the two hardware designs is that we have added some modules oriented to a more cost-effective aspect, let's say. So we have replaced the Wi-Fi and Bluetooth module, the flash. We are now using the QSPI flash instead the initial hyper flash that we had. A different audio amplifier and only 2 microphones instead of 3. Now, with this reference design, we did not lost anything in terms of performance. So it's as performant as the previous one. We are easily passing the Amazon qualification tests. It's just that the BOM cost was reduced, which is an important topic for our customers. I think that would be all from a hardware perspective. Now, on the software side, we are using Amazon FreeRTOS on this microcontroller. So obviously, it's not a Linux-based solution. For sure, we are having a driver layer for enabling all the hardware modules that we have incorporated in our design. And on top of Amazon FreeRTOS, we're having all these various modules. Now, I'll not talk about all of them because there are many, but I will quickly mention the most important of them. We are using lightweight IP for TCP/IP communication. On top of it, we are having emBET-TLS and, as Gitika said, MQTT for cryptography and for secure sockets communication. So this is a secure communication between our devices and the Amazon server. On the audio chain side, we are having the decimation engine, which is constantly feeding data from the microphones into our audio front end module. This is performing all kinds of processing over the microphone buffers like echo cancellation, barging, beamforming, and so on. And the result is being fed into the wake word detection engine, which is in the end that module which lets us know that the user has said the wake word. In our case, of course, Alexa. Now, in the end, I want to mention an important difference between the AVS for IoT and full flavor AVS devices. In this case, you can observe that the only local capability that we have on our devices is this wake word detection engine. While, from what I'm aware, in the full flavor AVS, there are more local capabilities. For some types of requests, the device is capable of replying directly from the local implementation, let's say, without needing to go to the cloud. Okay, I think this is all from an introduction from my side. I will now leave the floor to Dima for starting the demos, and I'll reclaim the floor a little bit later for showing you some demos of my own. If there are any questions in the meantime, please let me know.
Yeah, I think I had a question. So I think you showed an image of the solution, and Dima, you actually might be about to show us what this looks like, correct?
Yes, it was the
yes.
part of the
Okay.
demo.
Okay. So it's not going to be. This isn't going to be like an end product similar to an Echo Dot necessarily, if I understand correctly.
Yes, exactly. This is development kit targeting ODMs, let's say, and there are already some products on the market based on our solution, like the iDevices Instinct light switch. This is the light switch, and another light switch from Eaton. They are both devices that can be bought from Amazon.com as we speak.
Gotcha. So your clients' products eventually become the light switch that you mentioned from Eaton and
exactly.
like
Yeah,
gotcha.
based on our development kit.
Gotcha. Very cool. All right, Dima. I won't take any more of your time up. Why don't you show us?
Okay.
What's
So I
going
think
on? Yeah.
that's my turn. And again, my name is Dima, and I'm a software engineer at NXP, IoT Solutions team. Just let me share my screen so I can start share screen. And I will choose this screen. Okay, so I hope you see my screen. Can you confirm, please?
Yes, we can.
Okay, so first of all, let me just get you a little bit familiar with our device. So I show you ours. So this is our device, basically. And I think the camera video is not so good quality, so let me just show you a photo, an image, so you can easily better understand what is our device. And basically, just a high overview. We have the speaker, we have 3 microphones, and it is configurable if you want to use only 2 of them or all 3 of them. We have some switches with corresponding actions like changing the volume for Alexa, or a factory reset, or erase Wi-Fi credentials, or mute state, all other kind of features. On the back of the device, it is not, you cannot see it, but there is our microcontroller, our external, our flash, and all kind of other stuff. Okay, so now since you are familiar with our device arrives to our customers almost ready to be used. So it already has the firmware almost ready to be used and to be evaluated. So it already has the firmware installed. It has all the certificates required there on board. It already is registered to Amazon servers and so on. So the only thing is missing for a full experience are the Wi-Fi credentials. And now, normally, I would present you how to onboard our device with our newest enabled feature FFS. But instead, let me just tell you a little story. Let's assume our customer evaluates our device, likes it, develops their own product on top of ours, and now they want to produce, I don't know, 100 or 1,000 of such devices. How do they do all this? How do they onboard all these certificates, all this firmware? How they register it? And since there is a big quantity of devices, how do they do it automatically? And exactly for this reason, we developed at NXP for our solution an Evaldi tool suite, which basically is a tool suite for manufacturing production, making this process very easy. And just let me show you, first of all, how to prepare a device. So this is actually the first step, to prepare a device. One more thing, you can see here that on our device we have this little jumper, and it basically says, if I'm on the left side, I will run the code, so the device will be running the firmware. Otherwise, if I'm on the right side, I'm in serial. The device is in the serial mode. This means that the device is not running the firmware, but instead it is able to accept some basic commands. And for example, one of the commands is store this data into flash. And this is how we flash our device with the firmware and all the certificates required. So now I will quickly move this jumper to the right side. Okay, I will turn on the device. Now, what we need to do in order to use our Evaldi tool suite, which basically are just some Python scripts, but okay, there is a file structure there. We need to generate those certificates. It's a little bit more complex, but from a high overview, there are Python scripts in the end. Now, what I will do in this terminal, I will navigate to our environment. I will navigate to this tool and activate the environment which I previously configured. It is required to be done only once. Now I navigate to the path with the magic script, and what I do now, I just call this script. So I have the board in the serial mode, which is connected to my laptop, and I run this script. What happens now? This script connects to our device. As a first step, it erases everything from it. So we had a fresh start. Next, we will onboard all the firmware is required, which I previously compiled and placed in this tool suite environment. Next, it will also generate and upload some certificates for secure boot, for secure communication with Amazon servers, and also it will go and register our device to Amazon servers. And lastly, as a last step, it will also enable the FFS feature. This FFS feature, since it's as a standalone feature, it also requires some separate certificates. So when our device will try to connect to our smartphone or to another device in order to run the FFS onboarding, it will use these certificates to say, hello, I am here, and I'm registered. Amazon knows about me, so it's all okay. Okay, so now you can see that we are at the almost last step of the preparing. Now it's okay. So this is the last step, performing development FFS provisioning. So now it is created this FFS certificates and onboarded on device. This process, the whole process of onboarding, of preparing the device, takes around 1.5 minutes. And in the end, our device is fully ready, running, and the only thing will be missing are the Wi-Fi credentials. So our customers receive this device in this state, in this already prepared state. A few more seconds. At the end, it will also play an offline audio sound, so it can confirm that everything is all right. If you, of course, if you have any questions, you can interrupt me on the floor. And it's a little bit, sorry?
I did have a question actually. I noticed earlier on the product page, and I'll throw the product page up on the screen for everyone. It goes through the technical and functional specs, and it mentions the memory, and it mentions that there's, I believe, a megabyte of on-chip RAM. So do you use any like external SD-RAM as well? How does the firmware fit onto the device?
Okay, so I think I will answer this one. So yes, we have 1 megabyte RAM, and no, we do not use any external RAM. Actually, our firmware fits in this 1 megabyte RAM, and also we have some extra space, extra free space, which remains for the customer to add their own product or their own extra features to on top of ours. So no, we do not use any external RAM.
Okay. Thank you.
Okay. Thank you very much for your question. So now the process is done. All I need to do is unplug the device, move the jumper back, connect, turn on the device. So I will not need this anymore. Now the device will boot and we'll see that it is not yet provisioned with FF. It's not yet provisioned. And you can see, probably you can hear this offline sound. And now what we need to do is to provision our device using FFS. But again, I will not do it yet because I want to show you one more thing. So our device also offers a shell. So basically, if you connect it to a laptop or a PC or something similar, and you have a serial communication application like TerraTerm or Mobile Thermal, there are plenty of them, you can connect to our device. And by doing so, you discover its shell. So basically, now you can type some comments. And of course, the most important comment is help. If you type help, you see all available comments. Now, let me just show you some simple but useful comments, like serial number will display you the serial number of our device, like version will display the current firmware version which is running on device, and which is in our case 2.0.0, and it is running in bank A. In one of the future demos, I will explain what is bank A, because we also have bank B and how do we use them. As to your question, you asked for the memory. Now you can see that at this point we have available 140 kilobytes of free FreeRTOS heap memory. We also have our memory which is not yet FreeRTOS heap, also free. But as FreeRTOS heap free memory, we have at this point 140 kilobytes. And the most important comment for a developer, because our customers will also develop something on top of our product, is enable USB lock comments. By doing so, if we reset the device, we will see all the logs live. So before, sorry, it speaks. Okay, so basically these logs were previously also there, but they were not printed. Now they're printed, so you can easily understand if you're a developer, you can understand the flow, you can debug, you can do whatever you want, and this may be helpful. Okay, now the last step of this demo. Let's actually finally provision our device with Wi-Fi credentials. For this, I will mirror my phone screen. So as Gitika said, we enabled the FFS feature for our device. And basically, FFS comes in two flavors, UGS and ZTS. As a beginning, I will show you the first approach called UGS, which stands for User Guided Setup. And it requires you to have a smartphone or a tablet or something similar. And this is why I will share my screen. I will mirror my phone screen. 1 second, now you should be able to see it. Before jumping to provisioning, let's admire my beautiful llama from the work. Okay, now, as UGS, as I said, you need, for example, a smartphone. And what you need to have, also, this smartphone needs to have access to internet, so I'm connected to Wi-Fi. You also need to have Bluetooth enabled and locations enabled. I have already enabled the locations. And what you need to do now is to go to Amazon Alexa application. And what will happen when you enter the Amazon Alexa application? Amazon Alexa application will automatically discover the board over Bluetooth and offer you the possibility to onboard it. So by doing nothing, this pop-up appeared. You press continue. It asks you if you want to provision it. You say next, next, and after 2 nexts, and the device will start scanning for nearby Wi-Fi networks and will forward this information to the phone. Now you can see that I have this list of available networks, and I have two categories: previously saved to Amazon and the other networks. If I choose something from previously saved to Amazon, it will not ask me for the Wi-Fi for this particular Wi-Fi password because I previously saved it to Amazon Locker. Otherwise, if I choose something from other networks, it will ask me for the Wi-Fi password. So I'll just hit Stargate 100. What happens now is our device tries to connect to this Wi-Fi network, and if it succeeds, it will reboot and will perform the AVS registration, and the setup is complete. Let's wait a few seconds. Okay, so your Alexa device is ready. So it reboots. Now we can see the logs. This time it will boot and it will see that it already has the Wi-Fi credentials, so it will not enter the provisioning mode, but instead it will try to connect directly to this Wi-Fi network. You can also see that on my phone, this device was successfully registered. So I hit next, skip, done, and wait a few seconds for device to connect to Amazon, and we'll have a small check if everything is fine. Okay. And for example, now Alexa, device lost its connection. Okay, my network, something goes wrong.
All part of the live demo.
Oh yes,
Yeah.
this is the first time I see something like this. I will just reset it. That's unexpected, because you can see that on Amazon Alexa app on the phone, you can see that I have registered this device. To try to connect now. Okay, that's interesting.
Can you zoom into the shell as well? I kind of want to show the audience what's going on there just a bit.
Increase font size, increase font size.
Okay. So towards the bottom, folks can see it says MQTT Alexa attempt 1 to connect, and then it has an endpoint, an IoT core endpoint that I believe is trying to connect to.
Okay, I'll just make some room. Okay, so I think you see now the logs.
Yeah.
Alex, have you seen something similar previously? I think I did something wrong.
Yeah, I don't know. I think you have changed something in the demo, and it's the first time I've seen this. Anyway, you have provisioned it using Vijh. I can move further and present the zero-touch setup. And
Okay, yes.
hopefully the demo live presentation effect will not happen to me as well.
It happens. It happens at reInvent sometimes. Yeah. That's how people know we're live, you know?
Yep.
Yes.
Okay, so I'll share my screen as well right now. Just a sec. Okay. Please let me know when you are seeing it.
All right, we can see it now.
Okay, so I'm also sharing my phone. So what Dima showed previously was the user-guided setup flavor of the frustration-free setup. What I will demonstrate now is the zero-touch setup flavor, which is the more user-friendly version, let's say. So before going into details on how it works, I'll quickly show you how easy it is to use it. Now I will log in my device. I should have some logs anytime now in the console. Yep.
Your device is ready for setup.
And I'm also
Make
having
sure
my
Bluetooth
device here.
permissions on your phone are turned on. Then follow the instructions in the Alexa app.
Okay, now, so this is what we call the provisionee device. In order for it to be onboarded, it needs a provisioner device to set it up. Now, for zero touch setup, the typical provisioner is an Amazon device like the Echo Dot. Unfortunately, I don't have my Echo Dot with me. I forgot it at the office and I'm home right now. But luckily for me, the Alexa app can play the role of the provisioner as well. And within Alexa app, all you need to do is to have the Bluetooth and location settings turned on. Just turn on the Alexa app, and I shouldn't do nothing more than this, because as you can see in the logs, the onboarding has already started. So all I had to do was to plug in my device and have the Alexa app turned on. Okay, now the two devices are communicating. Okay, the demo effect is hitting me as well. So yeah, the onboarding should have happened automatically, but from where I'm standing in my home right now, I'm pretty far from the router, so the first connection failed. Now the second
Your
one
Alexa device is ready.
has succeeded, and
There we go.
the device was successfully onboarded. We can also see the messages in the Alexa app. Okay, so as you let's talk more on the user experience for this. In order for this flavor of frustration-free setup to start, there are some preconditions which need to be met. First of all, a product based on this solution, like the Eaton switch we've mentioned before, would need to be acquired from Amazon.com. The second condition is that the account used for acquiring that device from Amazon.com must be the same account that was used for onboarding the provisioner, like the Echo Dot, or the same account used to be logged in on the Alexa app. So that's the second condition, to use the same account here. The third condition is that the Wi-Fi must have been previously saved in the Amazon locker. And the fourth condition is that the two devices, the provisioner and provisionee, must be nearby so that they could communicate through BLE. Last but not least, an important thing about zero touch setup is that it was designed in such a way by Amazon that it is supposed to only trigger once in the lifetime of a product. So it's supposed to trigger only the first time you are plugging in the device after you have bought it and you have brought it at home, let's say. So it's aimed to make the first onboarding experience as easy as possible. Okay, so this would be all the conditions for zero touch setup. And now I'll try to demonstrate a few other features that we have integrated in our solution. Please let me quickly share again my screen, my phone screen with you. Okay, so I have opened the Alexa app here. The device should be provisioned now. So if I'm asking a quick question, it should reply. Alexa, what's the time?
It's 9:39 a.m.
As you can see in the
Enjoy
top,
the sunshine.
thank you. You are very polite. As you can see in the shell here, we are having logs for the microphone top microphone packages which are being sent to the cloud, and these are logs for the speaker packages we are receiving back as a reply. Okay, so now that I have validated that the connection works fine, I will go further and present the other features we have integrated into our solution, and I will start with the smart home capabilities. A few words about the smart home endpoints integration. Previously, for controlling IoT devices, someone would have need to create some Alexa skills to be able to control them through voice. But now, with these endpoints created by Amazon, it is much more easy to control such devices based on some templates made by Amazon. And our device is emulating a light switch device by default. And I will open the smart home device. This is how the user interface looks like. I'm not sure if you're also seeing my device in the. Okay, I should probably put it here because I don't have a fancy webcam as Dima had. Okay, here it is.
On top of your head.
Okay, and yeah, I can power it on. And as you can see, the LED turned on. I could turn on the brightness or turn it off, lower it, I mean, increase or lower the brightness. And you can see as well that in the console we are having some messages being printed when this type of events are happening.
So the LED that you're playing with, by the way, the audience should be looking at the red LED in the middle.
Yeah, that's the one. That when that gets turned on when I'm pressing the power is on or power is off button, and the same LED is being controlled. Just a sec. The brightness control is being done for the same LED. So the brightness increases or decreases based on my actions in the user interface. And now I should also be able to turn this off using my voice. That's the thing that was made easy by the introduction of these smart home APIs. Now the name is a bit longer, so hopefully I'll manage to control it from the first try. Is it on now? Yes, it is on. Alexa, turn off Alexandru Gabriel's NXP voice solution. And it should be turned off right now. I'm not seeing the message in the console. I don't think it got me. Alexa, turn off Alexandru Gabriel's NXP voice solution.
It happens to me at my home too, if
Yeah.
it helps.
The funny thing is that I'm hearing the sound. I'm not sure.
Yeah, we can hear
Just
it.
rename it. Rename it, Alex. If you go in Alex application right top, there is a gear. Rename it NXP device. I like to right top. Yes.
Yeah, I'm not sure.
Edit name.
To be honest, I didn't try this before the demo.
I tried.
Unfortunately, you tried it. Okay, great.
NXP device. It's the easiest.
Twitch stream NXP device.
Okay, and I should click somewhere. Just enter. Okay, now it is turned on. Alexa, turn off NXP device.
Okay.
Okay, it finally worked.
Oh,
It was the funky name that it.
Very cool.
nice.
Okay, so for an user, it should be for a client integrating our solution, it should be easy to migrate from this light switch template. Amazon has created quite an extensive set of smart home devices, and migrating to I don't know a new type of smart home should be easy. Going further, I will also demonstrate the locales capability that we have integrated. By default, as you can see here, at runtime, we are supporting all these locales. Now, what happens when we are changing from one locale? You can see that now we have the English United States being set. What happens is that an event is being sent onto the device, and we are reloading the wake word engine. Because we are having multiple wake word detection engines, as in different countries, people are saying the Alexa word differently. So that's why we need to reinitialize the wake word module. I will Now, besides these locales that are available at runtime, we also have multiple locales that are available at compilation time, and Dima will show you later on how to add another locale to the supported one. We are sticking with this by default because every local that we add increases the binary size, since we need to integrate into the binary the wake word module itself, and yeah, we had to choose only a few of them. But our clients integrating this will be able to increase, decrease, or just simply use the locales they're targeting, let's say. I will switch from English now to Spanish. Maybe we're having some Spanish speakers in the audience as well. Okay, as you can see here, we are having a log saying that we have updated the locales. It's this log over here. And now if I'm asking Alexa a question, Alexa, ¿cómo estás?
Muy bien, gracias. Estaba repasando los momentazos de los Juegos Olímpicos y me he acordado de Mireia Belmonte. Menuda crack en la piscina.
I'm not sure I got it all from the reply, but I got most of it. And what's interesting is if you ask a simple question in English, it will still reply in Spanish, like, Alexa, what's the time?
Son las 9:46 de la mañana.
Anyway, this is a cloud feature. I don't want to assume all the implementation here. Yeah, so we could switch to French as well. And again, locales report event is being published. Alexa, quelle heure est-il?
Il est 9h46.
Yeah, my French is a bit rusty, but I managed to.
Hey, you're a polyglot. Better than me.
Okay, now switching back to English. Okay, this was all for the local side. So what's interesting here is that we don't need to reset the board. The wake word detection is being reinitialized on the fly, and the user, after updating the locales in the Alexa app, can continue to use the board without a reset. We also have other features integrated here. An important one for the user's privacy is the microphone mute button, of course. So there are two buttons. I'm not sure if they can be seen because the power on button is pretty right, but there are two buttons right here. The switch number one is the microphone mute button. So right now the board is not on mute mode. So if I will say, Alexa, what's the time?
It's 9:48 a.m.
You saw that the wake word detection happened and that microphone packages were sent to the cloud. Now when pressing the microphone mute button, you have also heard the microphone off cue. There is also a message in the console saying that the microphone mute mode started. And now if I'm saying the wake word, it will not be detected. Alexa. No, sorry, that was a different device. That's a different event for it constantly asks for the clock from the server to be synchronized. So Alexa, and now I will unmute. You've heard the unmute cue, and now it should detect my wake word. Alexa. Okay, I thought that if I wouldn't say anything, it would be quicker. I might got it wrong. Okay, another feature is that we're having the tap to talk button. So the other button here, if we press it, we can ask a question to Alexa without having to say the wake word. So I'm pressing the button now, and afterwards you will be able to see microphone calls. Alexa, what's the time?
It's 9:49 a.m.
It was a reflex to say Alexa again, but it wasn't necessary. What's the time?
It's 9:49 a.m.
Okay. So this was it, and I think I'll end this part of the demo with a factory reset, which is being performed from the other button. I'll press the button for about 10 seconds or so. I didn't start counting, so I'm not sure how many seconds have already
8,
passed, but
7,
talking.
6,
Okay, maybe just a few more seconds, just a few more
6,
seconds.
6.
Okay, and I'll let it go now. You can see some LED displays. It started the factory reset, and it anyway, these are some logs that I'm restarting the shell here, and it should beacon again in
Your device is ready for
frustration.
setup. Make
Free
sure
setup.
Bluetooth permissions on your phone are turned on. Then follow the instructions in the Alexa app.
I'll once again try to do a ZTS. Maybe it will work flawlessly this time. I'm not sure. It has started to do so. The devices are communicating. It managed to connect. As I've said, the Wi-Fi connection is pretty poor in my working from home conditions. And it should reset anytime now.
Your Alexa device is ready.
And you can see also the notification. So yeah, I wanted to do it one more time because I had some connectivity issues initially. Now it worked from the first try, and you all saw how easy it is for a user to leverage frustration-free setup, the zero-touch setup flavor to be more precise. Okay, this will be all from me now. I'll leave the floor again to Dima, and I'll come back one more time with another demo in the end.
Before we do that, we saw a question from Sadman Sakib. And actually, this might be a question more for Gitika than it is for you, Alex and Dima. For folks who I guess don't have a lot of experience with IoT or learning about the cloud and trying to understand hybrid connectivity as well, Gitika, how would you answer this question? The difference between IoT and hybrid connectivity.
So let me see how I can frame it. IoT is essentially like if you have multiple devices out there and you have messages flowing in, like streaming, that would be something that would be called as IoT. Something which is all the time streaming in, coming in, the messages are there. Hybrid connectivity would be, I don't know. I'm falling short of words more if you want to jump in.
Like hybrid is in like maybe connecting cloud to an on-premises data center. That can kind of be hybrid.
IoT
Yeah.
would be more sensor based as well. Like you wouldn't expect that in hybrid connectivity. You always want the information to be flowing both sides. That might not be the case again with hybrid.
And Sadman, if you have any follow-ups, feel free to throw them in the chat. But in the meantime, why don't we pass it back over to Dima to show us the next demo? Actually,
one more thing I forgot to show, and I needed that because I'm mentioning in the last demo. I'll show is the bar gene that the bar gene feature we're having, and maybe Dima, can I quickly show it just a bit before you start?
I will let you.
Okay, you're very kind. So what is the bar gene? Bar gene is that feature where the sound which is being played on the speaker is being removed from what the microphones are being capturing. Because when you are playing some music on the device, you still want to be able to be detected. Your wake word utterances would still need to be detected. But since the microphones will capture also the music which is being played on the microphone, there are some operations which need to be made on the microphone buffers. So we need to subtract the data that we previously fed to the amplifier from what the microphones are capturing. And I'll quickly demonstrate that here, and I'll show in the end how we managed to do that and how we tune that when we need to. So I'll ask Alexa to play some music. Alexa, play a classical music radio station.
Wiper HD3 All Classical from iHeartRadio.
Okay, so now I will say the wake word and hopefully it will work. Alexa, stop. Yeah, so as you saw, the bargain worked pretty well, although the volume is pretty high. I'm not sure if it's being heard that well on the registration.
And to clear things up, this is a capability specific to Alexa built-in products and is something that is supported by. Oh, did I enable her?
Yeah, I just
it's a capability specific
don't know
to Alexa built-in products, right? Not necessarily like if something works with Alexa, it won't necessarily
well,
have the margin
works
feature.
with Alexa won't give you the possibility to talk to the device in the first time. So
No.
there's no wake word detection there at all. So, but this functionality is specific to all devices, IoT specific or not, because the Echo Dot, the full flavor of AVS, has this feature as well, the margin. Okay, I'm done. I'm really done now. We can start.
Okay, my redemption. Okay, of course I fixed the problem the moment I turned off the share screen. Actually, it looks like I missed the binary. I placed the wrong binary during the preparation. So the second attempt, but with another demo. Let me share my screen one more time. Okay, this one. And I think you see it. I think you see that I have attached some things, some extra hardware here. And before explaining you what this hardware is, I want to tell you something more. So previously, when I talked about our firmware, I was saying our firmware. Actually, in the background, we have three applications which are running sequentially. First of all, we have our bootstrap, which jumps eventually to the bootloader, which jumps eventually to our application. And we have two banks for applications. I will give you more details in a second. So bootstrap, the main responsibility for a bootstrap is the security. So it will jump to the bootloader only if the bootstrap is if the bootloader image is a valid one. Bootloader, on the other hand, has two main responsibilities. Again, the first one is security, so it will jump to the actual application of it only if it is a valid one. But the second responsibility of the bootloader is the firmware update. So bootloader, before jumping to the application, will check if there is a pending firmware update. It will download it, and it will download it in the opposite bank of the current application. So if we have our application in bank A and the firmware update arrives, it will be stored in bank B. So in order to do not override the initial application. Okay, so this is the theory. Now, picture with my setup. So you can see previously you saw the logs of our main application, but since, as I said, we also have bootstrap and bootloader, and you did not see these logs as well. This is because for the main application we get out our logs through the USB. Through the USB Type-C. On the other hand, for bootstrap and bootloader, we use our an UART serial connection protocol. And this is basically an adapter between UART and USB. So now, and you can see that I connected this to I connected to the RX and ground pins of the UART. Okay, so now basically if I open a serial communication application, and if I connect to it, I will connect basically now to the bootstrap and bootloader logs. And now if I turn on, sorry, give me a second. Nice. Now if I power on our device, you will also see the logs for our bootstrap, which jumps to our bootloader. And just give me a second, increase font size. Okay, and at the last step of the bootloader is to jump to this address 0x3000. This is the address of the bank A. So in bank A we have our default application, and now I also can oops, not this one, the other one. I can also connect in parallel to the shell. Okay, so here is our application. As I showed you in the previous demo, we are currently running in firmware version 2.0.0, and our application is in bank A. Now, let me tell you again a story. If our customer develops their own product and they sell their product to the customers, and tomorrow they find that they have a bug and they want to fix it, or they want to add a new feature, how to proceed with the devices they already sold? And for exactly for these cases, we added the OTA update capability using the AWS Amazon Cloud servers. So basically, what we had the capability for a remote update of the devices using Amazon servers. So let's for an example perform an OTA update.
So Dima,
Yes.
OTA, for those who don't understand the jargon and the parlance, OTA is just over the air, right? Over the air
Yes.
updates.
Yes.
Okay.
Yes. Okay, and first step, we need actually to create a firmware update. So we need to take our default image and to add something or fix something. And for this, the most simple way to do it is to use our Majestic MCU Expresso developed by NXP. We work on our software for this particular product in MCU Expresso IDE. Now, the first thing you need to do is to import the SDK. I also already downloaded the SDK, and the steps of how to download it are on the products page. So basically, there is a zip file which I can drag and drop right here. It will be automatically imported. So you can see it's SDK for NLX IoT. Now I need to import, let's import the default demo, which is currently running on our device, and it's called ACE FFS demo. On the other hand, you can also see that we have lots of other demos, including the bootloader and bootstrap, which I previously mentioned. Okay, like Hello World and other Wi-Fi examples and so on. But this time I will include the default one, and I will call it Bank B. It will take a few seconds to import. And as for actual update or fix or something, I propose to add a new locale, for example, Japanese. So basically, after we perform this firmware update on our device, we will have Japanese locale also enabled. And it's still importing, but it should not take too much.
Dima, how's your Japanese?
As Alex said, my Japanese is not so good. But instead, if I ask a simple question in English, Alexa will still answer in Japanese. So
There you
I
go.
have a Japanese conversation.
There you go.
Okay, so now I will quickly update some source code. So in order to enable the Japanese locale. So first of all, I will increase the number of locales. Next, this is optional, but I will also add it. This is the print for a log print, which says which locales are enabled. So I will also add the Japanese. Next, I need to say something somehow to our project to also compile the Japanese locales. So it is done by this define. I copy-pasted them separately in a TXT file, so we do not lose time. Also, next, we also need to say to the Amazon Cloud somehow, I know Japanese. So device knows Japanese. So this is why we also need to edit right here. And lastly, our device, for example, when it loses its Wi-Fi connection, and you say Alexa, it wants to notify you, come on, I do not have Wi-Fi connection. So it will say, sorry, your device lost its connection. And if you are, for example, you are using the French locale, you want this sound to be played in French. So somehow you need to also compile the offline audios for this specific locale. So this is why I also need to go to this file. All of these steps are described in our documentation, so this is why I do not really give you so many details. Okay, so this is enough to enable Japanese locale. Now, before actually compiling the source code, we also need to do some more changes in the properties of the project. First of all, there is a policy that if you want to perform a firmware update, the new firmware should have a higher firmware version. So as you saw, our current firmware version is 2.0.0, yes, 2.0.0, and let's increase it to 2.0.1. So here we have some macros. It's enough. You can set anything higher than 2.0.0, and I selected 2.0.1. Okay, and also since we are compiling for bank B, we need to specify that to the compiler we are compiling for the bank B. So the address is 60D. for bank B. Okay, now I hit apply and close.
Here, Dima, I just want to add something. We need to compile and we need to modify the start address of the binary because our code is not executed in place. So we need to specify exactly where it starts. We cannot have the same binary version running from different addresses in Flash. Okay, that's what I wanted to add in.
Okay, thank you. Let's continue. Now, let's assume that we already compiled the code, but it will take around 2 minutes. The one step we should also do is to sign this image because it is required and it is okay. I think it's okay to do it, to sign the image, so when it arrives to our device, we know for sure that this is our image, and so basically this is a security reason. And how to sign it? The easiest way to sign it is to use again our Vivaldi tool. Basically, in one of the paths from our Vivaldi tool, we have this signme.py script, and we'll need to place our binary right here. And currently in the output folder, there is nothing. So after we will sign it in the output folder, we will see it our binary firmware update signed. And since it's not yet compiled, let me give you a few more details. Because we will actually at some point at the end of this demo, we will actually perform this firmware update. How do we do it? Assuming we have the binary already signed. All we need to do is to navigate to AWS console. Okay. And here we have this beautiful create job button. Since we want to perform an OTA update for FreeRTOS, we select create FreeRTOS OTA update job. Hit next.
So Dima,
Yes.
I'll pause you there real quick. So you went into the console. You are in the console for AWS IoT specifically, and to navigate to this page, they go to Jobs, Create Job.
Yes, precisely.
Select. Gotcha.
Okay, thank you. And now let's have a name. And Howdy test. I like to test. Hit next. And our MC Express is still compiling. Okay, we can go further a little bit more. Now we need to specify what devices we want to update, and this is done by their serial number. So this is why I showed you serial number comment. This is our serial number, so I copy paste it right here. It has a small lag. A second. Okay, so this is it. Now we will let it as MQTT because we're using MQTT in our solution. I will use our signed custom file. And finally, this will be final steps in order to start the OTA update. The only thing is that we actually need the binary. So we will wait a few more seconds here. So it compiled. And I hope you enjoy looking at the compilation process. At some point,
We need to get you a PC upgrade, Dima.
Give me it. A few more seconds, I hope.
I think we can show this to our manager and you will quickly receive the laptop upgrade.
Okay, finally. And it will also say it how it took 3 minutes and 46 seconds. Okay. Also, we can see here at the end of the compilation process how much of the flash we consumed, how much DTC RAM, ITC RAM, and so on, how much RAM we have free, and so on. But finally, in this debug folder was created, and we need the binary. And if you can see, we do not have any binary file. But instead, we have this .axf. So if you just right-click it and go to binary utilities and click create binary, finally we get our binary. All we need to do it now is to sign it. So we just copy paste it here. And I knew I forgot something. Now we need again to open our Vivaldi tool. navigate to it and activate its environment, go to this signing path, and finally call the script to sign this binary. Finally, we are all done. We had this binary firmware update with a certificate appended and its signature. So now we need the signature in order to start the OTA process. Signature here, SHA26256. Say for bank B, we need to upload this firmware update. Again, here's some more details which we'll skip them because they're explained in the documentation and they're really boring. And finally, we can hit next. And finally, we can hit create job. All done. We are finally done, hopefully. Okay, the process is in progress. Now, if you check the logs, we can see that our board reset. But before reset, it received a notification which says increase font size, which says that we have an OTA update pending. Howdy test, which I just created. Now, if you go back to our Bootstrap and bootloader logs, we can see that our bot resetted. It went to Bootstrap. Bootstrap jumped to our bootloader, but this time bootloader, instead of jumping to the application, it now connects to the Wi-Fi. It connects successfully, connects to Amazon servers, to AWS, to IoT Core. And you can see that it starts to download chunk by chunk our firmware update. And yes, basically when this process will be done, when the old firmware will be downloaded, it will be validated by our internal certificates. And if everything is fine, the device will reboot, will notify Amazon, will notify this particular job that the job is done, and will start jumping to the new firmware instead of going to the old firmware. So basically, that's it. All we need to do is now to wait. And I'm ready and happy to answer any questions.
Yeah, while we're waiting. So you walked us through a few things here. One of them was Evaldi. And so for anyone who joined, I know you talked about it earlier. Could you remind us what the Evaldi product suite is and kind of what you were using it for?
Sure. So Evaldi is a tool suite developed by NXP, especially by our team, which may be used for manufacturing and production by our customers. So basically, we have after you set up it, again we give all detailed steps how to set up it, and it is not so hard. For example, to prepare a device, it is enough to just run a script, and in 1 minute and a half, it will onboard with all the required certificates and firmware of this device. On the other hand, if you want to prepare a firmware update, you need to sign your image. And again, you can use Evaldi to sign this image in order to send it to Amazon, in order it to be forwarded to the device, and in order to replace the old firmware with the new one.
Got it. So are all of your customers going to be using Evaldi? New customers? I guess. At what point would you start using Evaldi? Yeah.
Okay, so if you are a new customer and you just want to evaluate the device so you can understand if you want to continue with this device, you do not use Evaldi. You do not need to use Evaldi because the device already arrives prepared. You just need to turn it on, perform an FFS, UGS or ZTS, and evaluate the device and understand if you want to proceed with it or not. Otherwise, if you are a customer who evaluated the device, develops their own device, their own product based on ours, and at some point they will want to prepare 100 of devices. And at this point, if you do it manually, you just add flash certificate by certificate with your hand there, manually do so, it will be very painful. And instead of doing this, our customers most probably, I think 99%, will prefer at least to listen what is Evaldi, and after we present them, I'm sure that they will want to use it. Okay. And finally, if you refresh this page, you will see that this process is completed. If you go to it, we will see that it is succeeded. In the bootloader, you can see that bootloader jumped to this specific address, which is the address of bank B, 0xd000. And if we go to our shell and we hit version, we will see that the firmware version is 2.0.1, so the new one, and we are currently running an application B. And the last step for this demo, let me again show you that Japanese locale actually is present. And I will again just mirror my screen. somewhere here I lost my device. Okay, here is it. And if I go to Amazon Alexa application, and if I go to devices, all devices, my device, go to language, I can see here that I have Japanese enabled, compiled, and is ready to be used. And now if I go with Alexa, what time is it?
午前10時15分です。
I think, did you hear?
We did hear, yeah.
Yeah.
Okay, that's the best of my Japanese. Okay. And I think that's all for this demo. If you have any questions.
Gitika, do
Okay.
you have any questions?
No, I loved the demo overall. I think that was pretty interesting. I know I've had issues with my Alexa taking responses, so Alex, I completely understood your pain when you asked twice. Um, but yeah, I loved having you guys over for this. I'm not sure more if you had any questions. And actually, I do. So we already shared the link with everyone for where they can actually go. Is there any other thing that they need to keep in mind, anywhere they need to register or contact you for them to be able to set this up? Or can they just order from your website and then get started directly?
Okay, no, I think it's all on the product page. I still had one small demo though, so we're not really done with what we were thinking to show you guys.
Yeah, of course. We have plenty of time, so we'd love to
Okay,
see it.
so I've mentioned earlier the margin feature, and I'm going to show you how we are tuning that. I flashed a new device. I flashed a new project on the device, and it will start to play a chunk from Metallica. Nothing else matters. Please let me know if you're hearing it.
Yeah, like
And what I will do in this demo is that the demo extracts via USB all the microphone streams and the clean sound stream and the amplifier stream, and basically I will show you how the streams are being aligned and how to tune it if they are not aligned, so that the margin experience is as best as possible. And when the user utters the wake word during playback, the wake word is being detected. So I'll plug the board back in. I will. How is this demo working? When I'm saying the wake word, it will light a blue LED. So Alexa, 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 Alexa. As you can see, the blue LED gets lighting every time I'm saying the wake word. Now I'm going to quickly share my screen to show you the. Where is it? Yes, that is. Oh, just a sec. I stopped. I forgot to share the audio as well. Okay, share system audio. Yes. Okay, can you see my screen?
yes, we can.
Yep.
Okay, great. Now we're having a script here. I will start it. It will start to capture the streams, as I've said. I'll call it test 4. And I'll start again to say the wake word a few times. Now it's easy because it's quiet, but Alexa, Alexa, Alexa. A few more seconds to get the music more advanced, let's say. Alexa, Alexa. Okay, I think this is enough for this demo. Now I will end the script. And I will also stop the music. Okay, so what
So,
this.
so Alex, the goal here is to tune the bargain feature so that whenever you say Alexa and there's stuff playing in the background, you can actually use the wake word. Is that what you're
Exactly,
saying?
exactly.
Gotcha.
The sound which is being played needs to be subtracted from what the microphones are being captured are capturing. So only the voice, the user voice, will remain, and the record detection will successfully detect the. Oh, what is this? What have I done? Just a sec, please. Okay, so these are all the streams that have been extracted previously. We are having a stream for microphone 3, microphone 2 here, microphone 1. This is the cleaned sound from the AFE, and this is the amplifier sound. So this is basically, if I'll select only this one, and if I'll play it, we should hear, hopefully we will hear only the music that was played. Can you hear it?
Yep, yes, we can.
Okay, so this is what we have sent now to the amplifier. I think this was the pause when the music has stopped playing, and here is when it started again. Now these are the microphone strings, and if I'll play this one, you should hear both my voice and the music combined in the stream.
And I'll start again to say the record a few times.
Yep.
Now it's easy because it's quiet, but Alexa, Alexa, Alexa. A few more seconds to get.
Okay, and on the clean sound, we will see that only my sound should be heard. There are a bit of artifacts at the beginning, I think.
And I'll start again to say the record a few times. Now it's easy because it's quiet, but Alexa, Alexa.
And as you can see, here we already have the music
Alexa.
started, but you're only hearing me.
A few more seconds to get the music more advanced, let's say. Alexa, Alexa. Okay, I think this is enough for this demo. Now.
Okay, so what it happens when a customer comes and creates a new design is that because they're placing the microphones differently, or because the distance will be different between the microphones and the speaker and so on, the delay between the amplifier loopback and the microphone streams can be different. So they will need to insert software delays in order to have the loopback and the microphone strings aligned. Otherwise, the AFE engine will not be able to find the audio played through the amplifier. It will not be able to detect it on the microphone stream. So when that happens, typically the user would basically need to zoom in quite a lot in this, maybe not in this one because it's not relevant. So this is the amplifier one, what was being played on the speaker. And this is the microphone stream. So what the microphones captured, I'll zoom a little bit more here. And they will need to be aligned on a millisecond basis. The Metallica tune is not the best for doing this kind of calibration. We have some special sounds where it is much more easier to detect where the sound starts, let's say, but roughly it should, okay, I lost it. It should look something similar to this one. Now, as you can see, it's not perfectly aligned, but our AFE engine is capable of tolerating just a bit of delay. But if this would be, if the difference here would be bigger, the barging would fail for sure. And on the clean sound, you would not be able to hear only my voice. So the barging experience will be poor. When that will happen, we will try to synchronize these two streams, let's say. So that's how we are doing it, and that's how the customers which are using our solution are doing it as well. So yeah, this concludes our demos.
Nice.
If you guys have any other questions, please let us know.
Yeah. So you did mention the one question that I had. You mentioned AFE, I believe. Could you? I think that's maybe audio front end.
Yes, that's the audio front end.
Okay.
Yeah, sorry.
No problem.
No automatism for us already. Yeah.
Yeah, okay.
So it does this kind of feature of manipulation on the microphone streams for barging, echo cancellation, subtracting the amplifier sound, beamforming, and providing in the end a sound as clean as possible to the wake word detection engine. So the wake word detection engine can be able to detect what the user says as best as possible.
Got it. Okay. All right. So I think that concludes all the demos. Actually, Alex, maybe, or Dima, I want to go back to you two, and give us a summary, if you could, of all the demos that people saw today. We'll start with Alex. Actually, I think you kicked us off, or was it Dima who kicked us off?
Yeah, I kicked this off with an introduction about our solution. Then Dima.
Then yes, I showed our Evadi2 suite, which this is designed for manufacturing production, followed by a first provisioning using QGIS. One flavor of FFS. Sorry.
Afterwards, I continued with demonstrating the zero-touch setup flavor of the FFS, and then I showed the locales feature, the smart home API integration, and our action buttons, mute button, and factory reset. And I think that was all.
Okay. Then I showed how to enable a new locale for completion for our project and how to perform our OTA remote update of devices.
Yeah, and in the end, I showed how we are tuning our margin performance using our USB AAC alignment tool here.
So, if either of you had one takeaway from the audience about what they saw today, what would that be?
Maybe the zero-touch setup.
I really like the barging thing. When you know that you have two streams, and if you subtract the one from the second, you obtain
that's
sound.
cool as well.
Yeah, I thought so too. I thought it was really cool to see, in particular, when you played the audio for like the song itself, and then you were able to show the extracted audio for the wake word. I thought that was very cool. What about you, Gitika?
For me, I think that was also pretty cool. I was actually kept wondering what would happen if there was a lot of noise around you, and not just music. Would it show like similar impact? I would guess yes. But that was very cool because I haven't seen a simulation like that. I know it does happen. I know other people have worked on similar projects, but that was a standout for me as well.
Yeah.
Well, in order to be qualified as a AVS IoT kit, we had to pass some pretty tough qualification tests, and we are able to do that by quite impressive margin, let's say. There are some thresholds above which or under which you need to be, and we are doing pretty good in there. So the tests include near field, far field, and noisy conditions, and so on. In a special lab where there are multiple speakers placed in various places, and some of them are playing, let's say, a noise sound, and we're having another speaker playing wake word detection utterance from the user, and then the whole test setup, which is being developed by Amazon, by the way, detects if the wake word detection happens or not.
Very cool. So I'm gonna throw the product page up one more time. You should be able to see that on the screen now. Gitika, why don't you summarize? Like, what's the biggest takeaway that you had from everything that you've seen today?
For me, I feel like the biggest takeaway was like how simple it was and how simple NXP has made it for any corporation to take their product and incorporate into their product altogether. I feel like the overall process that Dima and Alex showed was pretty simple. I loved how each and everything was put out properly. Like, even if things weren't working, they actually told us what was not working. And it happens all the time. But for me, that was the major takeaway: how to work with NXP's products, how to get it all set up, and how frustration-free setup comes into the picture, and how easy it is that NXP has made for anyone using it.
Yeah, the IoT world is so vast, and so it's nice to have partners like NXP here showing us what they can do and how folks can get involved and build products that leverage the IoT capabilities that NXP has and that AWS has, which is very cool. All right. So I think that sums it up for today. Alex and Dima, so I have to say the show was made in Texas. That's why we use the word howdy. And so it's tradition on the show that we end with a sign off. And so we'll give you options. Typically it's giddy up, y'all come back now, or happy trails. So of those three options, how do you want to end the show? We'll start with you, Alex.
Could you repeat, please?
Yeah.
I remembered Happy Trails, so
Happy trails. Dima's going with happy trails. What about you, Alex? Happy trails, giddy up, and y'all come back now.
Y'all come back now.
Y'all come back now. There we go. Gitika,
Giddy up.
giddy up. All right. And happy trails from me too. Join us on Monday, regular scheduled timing. We'll have our next partner. I believe it's in Perva. Doing
Yes.
some cybersecurity stuff with AWS. So I'm excited about that. Thank you, everyone, for joining. And we'll see y'all later. Happy trails.